Filter is the most powerful function that you're not using. Here's how it's really going to level up your Excel game. I find this function really useful in all sorts of scenarios. Unlike X or VLOOKUP, which only return the first matching result within a dataset, the filter function returns every record that matches a set of criteria. It also beats out the static filtering seen in the tables. Any changes to the underlying data or to the filtering condition automatically result in an updated set of values, so you don't need to remember to go and reapply that filter all over again. This means you have the data you want every time. Let's dig in on how to use it to better your workbooks. If you're new to the channel, hi, I'm Elliot and I make videos all about Microsoft Excel. Over the past few years, I've gone from a beginner to reaching the final 32 in last year's Microsoft Excel World Championship. And yes, that is a thing. This year, I'm hoping to make it all the way to the Grand Finals live in Las Vegas. So make sure you subscribe to the channel as I'm sharing everything I've learned, as well as what I'm doing to prepare for this year's competition so that we can excel together. Despite being unknown and underutilized, the filter function is relatively simple. All it takes is two arguments. The first is the data you wish to filter, and the second is the include array for how to filter that data. This second argument should be a series of true and false values, where true means keep this data and false means filter it out. Filter can work horizontally or vertically, and the way you specify this is through that include argument. If you wanted to filter out particular rows, you would pass through that include argument as a single column with as many rows as there are rows in your data, with a true for anything you want to keep and a false for anything you want to remove. On the flip side, if you wanted to filter out particular columns, your include argument should be a single row with as many columns as there are columns in that data. Again, true tells Excel that you want this record in the output, and false says get rid of it. This can take a minute or two to get used to, but once you do, you'll find it's really intuitive, and it's great to have the flexibility of both options built into the one function without having to have an additional argument to specify which way you're filtering. If your include argument is too long or too short, Excel will return a value error to let you know something has gone wrong. There are also a couple of other errors it can throw if something has gone wrong. If you pass any errors in through the include array, filter will return the same error as the output, so it's important to make sure you've done some data cleaning before you pass it through the filter function. Finally, if there are no true values in your include argument, it will return a calculation error. There is actually a third optional argument for the filter function, which lets you specify what happens in this particular case. Anything you include in the place of this third argument will be what is returned instead of a calculation error if there are no matches. This is great for helping differentiate whether there are just no results, or if the error is due to something else that's gone wrong with the data you're passing through. I would really recommend using the built-in error handlers in some of the more modern functions when you can, because wrapping things in an if-error statement hides all sorts of other things that may have gone wrong with your data. To have a look at this function in action, we're going to explore a dataset about media from the MCU. Here we have a list of TV shows and movies from the Marvel Cinematic Universe. We have their name, whether it's a movie or a TV show, the year it was released, their Rotten Tomatoes rating score, and the main hero or main team that appears in that piece of media. If we wanted all the details for all the TV shows, we would simply type =filter, select the whole dataset, and then as our second argument, pass through this second column equals TV. This gives us exactly what we're looking for, allowing us to create a report or further calculations based on just those TV pieces of media. The way that this works is that this second argument is actually a dynamic array. By using the statement these values equals TV, we're actually returning a dynamic array with as many rows as there are values we're passing into it, where it's true where it's a match, and where it's false where it's not. In this case, false where it's a movie. We don't have to do it this way. Instead, you could create a helper column if that's something you're more familiar with. In this example, we'd simply put equals B2 equals TV, and then flash fill that down, and then we could use this range as our filter values. Because your filter values don't have to appear in the data you're filtering, we don't need to return the entire dataset if we don't want to. For example, if we wanted the names of all the pieces of media where the Avengers were the main hero team, we could simply put =filter, the name column, and then as our include argument, put the main hero equals the Avengers. Of course, you could also do this through a helper column as discussed earlier, but I do prefer not including random columns of trues and falses if they're not needed for anything other than this one filter. What if though you had some more complex criteria for filtering on? Say for example you wanted the names of all movies that came out after 2015 with a Rotten Tomatoes rating score of 90% or more. This is one example where clarity may win out against efficiency. For many people, the easiest way to do this would be to create a helper column. That helper column might look something like equals and B2 equals movie, C2 greater than 2015, D2 greater than or equal to 90%, or if you prefer, 0.9. There are a few ways you can do this within the filter function itself if you don't want an extra helper column cluttering up your data. You may think it's as easy as taking our helper column and changing it so it's referencing each of the 3 columns for these criteria. However, if you do this, the AND function will only return one value, true if every single row matches all 3 of those conditions, and false otherwise. This isn't what we want, as we need a column of data with as many rows as there are entries in the data we're filtering. One approach to this would be to use by row. By row is a really useful modern function in Excel that calculates things one row at a time, just like the name suggests. It's a valid solution and it will work. If you had a go at this, I would love to hear about it in the comments. However, it's a little bit advanced for a video just introducing the filter function itself. Another alternative, which is the one we're going to explore here, is using the fact that behind the scenes, Excel treats all false values as a 0 and all true values as a 1. Here we're going to leverage the fact that if all 3 values are true, we want it to be true, i.e. 1, and if any of them are false, we want it to return false. There's a simple operation you are used to that does this behaviour: multiplying. If you have 3 values and you multiply them together, and any of them are 0, you're going to get 0. Whereas if all of them are 1, you're going to get 1 as a result. We can use this to create a dynamic array to filter this data the way we're looking for. We can do this by putting each of the individual column comparisons in brackets and multiplying their results. In this example, media type equals movies, times year greater than 2015, times rating greater than or equal to 90%. This gives us our list of true and false values exactly as we're looking for, and we can get the same results as if we'd used that helper column. None of these solutions are inherently superior to the others, it all depends on the usability for you and anyone else using those workbooks. Sometimes simple is best, it really depends on what you're doing. That's great if we want to do an AND condition, but what about if we want an OR condition? Let's say we wanted everything that featured the Avengers or Spider-Man. We could create a helper column that simply equals OR E2 equals the Avengers, comma, E2 equals Spider-Man, which is the quickest and easiest solution. You could also use by row if that's within your wheelhouse. To do this in the same manner as we approached the last one though, we're going to have to expand our definition of true a little bit. You see, while Excel does treat trues as 1s, it will actually count anything other than a 0 as a true value. This means that we can use addition rather than multiplication to get the results we need. This way, if they're both false, it will be 0. If either one of them is true, it will be 1. And if they're both true, then we'd get a value of 2, which Excel would still treat as a true value. This works just like the previous example. We wrap both of the conditions in brackets, and this time simply add them rather than multiplying them. Easy. You can combine all of these together, add things up, and then put that in a bracket and times that by something else to have an AND or type of statement, but that's beyond the scope of this video. It's worth playing with though, because it does come in handy now and then. Finally, I want to talk about the if empty argument. As I stated before, this simply lets you specify what to return in the event there are no matches. For example, if we filter this dataset based on the main hero being Batman, we would obviously get no results because there is no Batman in the MCU. By default, this returns a calculation error. The if empty argument though lets us tidy up what we're returning by specifying what we want to say. For example, we could make it say, does not appear in the MCU. Likewise, you could set this to a value, a blank string, a calculation, maybe an average of something else, pull something through from another workbook, completely up to you. Because this is database though, you can make it a little bit more dynamic. For this example, you might want to use your lookup value in your return statement as well as your criteria statement. So you could make it say, Batman is not in the MCU, and if you changed it to Superman or Wonder Woman, it would automatically update what it's returning. The filter function can be really powerful for creating models, dashboards, and even just exploring data. However, I don't use it anywhere near as much as I do XLookup. XLookup for me wins out. The fact that you can use it to not just look up values, but also to assign values based on ranges rather than using lots of nested if statements makes it one of the most powerful functions in Excel. Make sure you check out my nested if statement video for an example for how to use this advanced feature of XLookup. That's all for the filter function for now though, so until next time, keep excelling.